Proton model and some problems discussed. My model for the proton is simplicity itself. A proton is made up of 2 positrons and 1 electron. That equals an exact charge of +1. But it does raise valid questions. This post answers many that I've got. Then in the notes, I'll add a meta AI quote on the implications of my model. Problem: what about quarks? Response: when a proton and antiproton annihilate, they mostly turn to mesons, which are quark pairs. But the mesons are a transitional state and almost immediately turn into the final state of electrons, positrons, and photons and neutrinos. No quarks are left, while the electron and positrons make up my model of the proton. Problem: your model is of a proton as 2 positrons and 1 electron, but those 3 particles have much less mass than the proton itself. Response: the same experiments that have proton and antiproton annihilation end up with positrons, electrons, photons, and neutrinos. The combined mass of what's left is much less than the proton. So the problem is in both models. The answer is most likely some type of binding energy that makes up the difference in mass, though that is my guess only. Problem: the experimental evidence for quarks comes from particles scattering off a proton. They show 3 smaller particles inside the proton. These 3 inside particles do not share the same charge. Response: my model has 3 smaller particles within a proton, and they are not the same charge either. 2 positrons and 1 electron. Problem: wouldn't the electron and positron in your model of the proton annihilate immediately? Response: first, a proton charged +1 and an electron charged -1 do not annihilate. To annihilate, there has to be a particle and its antiparticle. That means 1 electron and 1 positron. That is not the case in my model. The 2 positrons make a ring with a single electron inside it. Therefore, a single electron will not annihilate with the 2 positron ring. For the neutron, I add an outer electron to get 2 positrons and 2 electrons equal charge 0. The extra electron of this neutron will not annihilate with the positron ring either. Problem: what about the strong force within the proton? Response: the 2 positrons in my model form a ring that circle a center electron. This ring is extremely stable. Let's say this ring is like a rubber band. The force that stretches the rubber band outward builds up an ever stronger counter force to snap the rubber band back to its original ring. Therefore, the strong force may come from trying to break the positron ring. Next, here are some positives of my model. This suggests where the antimatter is. The antimatter is in protons and neutrons. This suggests the strong force within the proton may not be a separate force. This suggests why the charge of the massive proton and the tiny electron are exactly the same. This help explains beta plus and beta minus decay.